All right, let's talk space. All right, in the Space Lab Life Sciences payload, 14 male rats were sent to space. Ooh, that's a tongue twister, wasn't it? Upon their return, the red blood cell mass in millimeters of the rats was determined. A control group of 14 male rats held under the same conditioning, except for the space flights, as the space rats, and their blood cell mass was also determined. 2 separate groups. We actually have 28 rats. 28 male rats. 14 went to space, 14 didn't. 2 separate groups, independent groups, right? So I know I keep beating the same drum over and over again, but I want to make sure you're hearing it. The project resulted in this data, PAPOW. And here's the question. Does the evidence suggest that the flight animals have what? A key word right there. Different red blood cell mass from the control animals with this level of significance. So we have 28 rats. 14 were in flight and 14 stayed on base, I guess, or wherever in the science lab that we're going for. Now, here's the deal. I'm going to fling back over here. We've got all these criteria that are associated with it. Completely randomized, nailed it. 2 totally separate, nailed it. Now here's the rub. These are not greater than 30. They're small pieces of data, so we're going to have to make sure that it's normalized. However, 14 rats, absolutely less than 5% of the rat population, so we're checked out there. But these are nice plots. StatCrunch does it for you. Notice, you have to have 2 because I have to normalize this data independent of this data. So this is like N1 and this is, oh, that looks like an M. N2 and N1. Separate pieces of data, right? So I have to make sure this is normalized because that is less than 30 pieces of data. Check, we're cool. Have to normalize the control group. Check, we're cool. Do I have any outliers in the control group? Nope. Do I have any outliers in the flight group? Nope. We're now good to go. Once we take care of all of our business, now we're good to go and we can set this up. So let's make our hypotheses. Let's scoot this up, trying to get both of them in here so we have the info. So this is saying I want to know where the mean of my first group is going to equal the mean of my second group. That is my null because they are both sets of rats, right? That looked weird. And so that's my null hypothesis. Now my alternative hypothesis is saying, okay, what do I think is going to happen? I think they're going to be different. That's what I'm trying to determine. So what is different? Not equal. Is it greater than? Is it less than? I don't care. I just need to know that it's different, and that's what I'm going for. All right. I'm going to write this or in here because I want you to see sometimes it's written like this. mu1 minus mu2 does not equal 0. Either one. Typically, we're going to write it like this, but I want to make sure that you see what both of them look like. All right. The symbols are the same. All I've done is just move this second mean to the other side of that equal sign. That's it. All right. Okay. Now, again, in StatCrunch, in your, oops, I wanted to write it like this. In your homework, you're going to have the little double box, which if it's in your homework, you know, it'll be on your quizzes and tests. And then you can open in StatCrunch. And then it automatically populates into StatCrunch. Well, these are notes. So our notes doesn't automatically populate into StatCrunch. So because of that, we are going to actually go into StatCrunch. All right. And we're talking means again. So let me scoot this over. But I have 2 separate pieces of data. Now here are my 2 separate pieces of data. We're going to go to, oopsie daisy, stat. These are means, but I have a 2 sample. That's the diff. Stat T-stat, because anytime we're dealing with a mean in this class, we go to T-stat. But I have two independent pieces of data, so that's what makes it two sample. Now, you can either have with data or with summary. I want to show you what the with summary looks like because it has two separate options to put information, right? Two completely separate places to put that. For us, we actually have our data because that's what's put over here. So we're going to go with data. And whenever I go with data, I'm going to have to put variable 1, variable 2, and then here's a setup, right? Because this is how StatCrunch does it. That's why we showed, I'm going to bring it back over, these two separate ways to do this. Whether I have these together or separated out, same deal. Does not equals what we're already going for. So now I'm going to compute. And I want my P value, which is right here. All right, so I'm getting these differences between the means. That's what I'm working with. And just that it is different, so it's not equal to, I get a p-value of 0.1627. 0.1627. Scoot this up a little bit here. 0.1627. Okay, so whoopity-woo, right? Great, we've got a p-value of 0.1627. Who cares? We care. Why do we care? Because that is how we determine if we're going to reject, right? Boom! Same thing we've been doing this whole time. So if the p-value is less than my level of significance, we reject. It's always nice to put this little reminder over here just so that we have it. Well, what's my level of significance? 0.05. What a shocker. So 0.1627. The question is that less than 0.05? No. No, it's not. Nope. 0.1627 is greater than 0.05, so we do not reject. So what this is telling us is we're saying, regardless, I'm going to scoot this down a little bit, regardless of if my rats were in space or if they were in the lab, is there a difference between the red blood cell masses? No. I'm pausing for effect. Do you see what just happened there? When you have this data, yeah, we math it out, but I really want to make sure you understand what's going down. So what we just determined based on our hypothesis test is we're saying with just a 0.05, so we're 95% confident that whether these rats are in space, their red blood cell mass versus the ones that are not in space, there is not going to be a difference. My null hypothesis says those two are going to be the same. Those are equal. So we do not reject the null, which means what is stated is what we go with. All right? So we do not have enough evidence. So there is not sufficient evidence. All right, just keep writing the same thing over and over again to conclude that the flight animals have a different red blood cell mass from the control animals. And the more Experiments like this that are done, this is the kind of stuff that was done just to make sure that everything is safe to send people up, right? That's just how that works out. I'm going to make this bigger. So these 14 male rats were sent. Okay, let's come back. Is it going to jack with them? So is it going to jack with people, right? That's what they're trying to figure out. And that's why these kinds of experiments are done. And that's why statistics is important. Yeah, we get these back, but I'm looking at 14. Is 14 exhaustive? Oh, we got to send people up here and try to figure this out, right? So that's where statistics comes in. Let's run these tests with statistics. Let's figure this out. No, that's not going to be a problem. Hey, there is not sufficient evidence to tell me that what we are saying, that the fact that these are equal and it's okay, that is legit, right? That's the beauty of statistics. We work together with our science in order to come up with valid pieces of information that we can pull this off with. Pretty cool, really.